Hey there, Bulldogs. It's been a while, but don't worry. We're now back with some videos for our next unit. So this is the first one on the scientific revolution, a just brief overview of some of the background on it. So we're going to start talking about some of the ways that people viewed the universe back in the medieval time versus how the scientific revolution caused people to change their view of the universe. This looks like some of the photos you guys submitted for your telescope example. So all right, where do we start? Let's start with the Earth. Okay, so in the medieval time, the idea was that the Earth was the center of the universe. Not the sun, but the Earth. And it stayed fixed, and around it rotated everything. The stars, the moon, the sun, the planets, everything rotated around the Earth. So the moon would go around the Earth, the sun would go around the Earth, all the planets like Mars and Jupiter would go around the Earth, Venus went around the Earth, pizzas went around, wait, no, pizzas did not go around the Earth. We know that pizzas were not around during medieval time because tomatoes are from the New World and pizza was not in Italy yet. We know that. So not pizzas, all right? This was the medieval view, okay? So like pre-Renaissance, right? And this view was around for a very long time. This was known as the geocentric theory. Little SAT practice here. Geo, think Earth. So geography, right? Study of the Earth. Centric, think center. So Earth-centered theory. Aristotle believed this theory. You may have heard of him before. He was a philosopher and most known for his writings on politics, but he also studied math and all this stuff. He was born 384 BC, like I said, a Greek philosopher. Now, he's known as a genius. Is he still a genius if he messed this up, right? I think everyone makes mistakes, including people like Aristotle. This is also often called the Ptolemaic system because Ptolemy, this guy here, he supported this model. He was from Alexandria, back from the ancient Roman Empire. He was born AD 100, so quite a while after Aristotle. So he was a mathematician, an astronomer, a geographer, and he says, you know, hey, this is how it works. And the Ptolemaic system really wasn't challenged for like 1,300 years. Now, there was an individual, Aristarchus of Samos, who came up with something different, but that didn't really get any attention. So when did something else get attention? Oh, I should mention also, the church supported this theory, right? The church is like, of course, God would put Earth in the center of the universe. Why would he put anything else? We're here on Earth. God, this is God's place. We're in the center of the universe, right? Plus, it was supported by sayings in the Bible, which we'll get to in a little bit. So next we have the different theory, which is the heliocentric theory. So helio, think sun, centric, think center. Okay, so this is developed by this guy, Copernicus, and he was born in what's now Poland in 1473, right? So during the Renaissance. And he thought, no, Ptolemy was wrong. The sun is the center of the universe, right? And everything rotates around the sun. So he had observations and data to support this, but he was afraid to publish it. Like, people are going to want me dead because of this. That's crazy, right? But so he did not publish his findings until basically the year he was dying, and he knew it would be safe. And this book was called On the Revolutions of the Celestial Spheres. So think like planets, celestial spheres, right? So he really didn't make this view too public during his lifetime. And we have others that then support Copernicus, namely Kepler. Now, Kepler was born in 1571 in what's now Germany/Austria, and he wrote a book on the laws of planetary motion. So he supported Copernicus's theory that the sun is the center of the universe. However, he didn't think that they went around in circles. Remember, in the Renaissance, a circle was the idea of the perfect symbol. So that would sort of go in line with that thinking. But he's like, no, the orbit's really more like an oval. So he changed that around a little bit. And then we have others that add to this theory, like the famous, you all know, Galileo. Now, Galileo was born actually before Kepler in 1564 in what's now Italy, in one of those like Pisa. And he made a lot of discoveries. You see him there holding his telescope when it comes to science. He discovered the 4 moons of Jupiter. Well, he discovered these 4 moons of Jupiter: Ganymede, Euclides, Celestio, and Io. So he's like, hey, we don't just have moons. Jupiter has moons. He discovered that the sun has dark spots. So, you don't want to be staring into that, but he noticed that. He also discovered that like the moon, for example, is made out of not this pure celestial heavenly substance like that people thought of. Like, like there's like rough patches on the moon. It's like rocky or whatever. Most people thought it was made out of nougat, that stuff in the middle of Three Musketeers bars. So, that's what I would think a celestial thing is. What's more heavenly than that? So he made all these discoveries. Now, there's the moon, and it's not nougat. However, he got himself in some trouble here because, as I mentioned before, the church supported the geocentric theory, and he was like out there supporting Copernicus's heliocentric theory because there's a passage in the Bible that says the world is firmly established. It cannot be moved. So to be saying anything else is like challenging the authority of the Pope. So he literally had like this he had to defend himself, and he got himself in some trouble, imprisonment, this and that, and this went on for years. So basically saying that like it was controversial to use science if it contradicted with established doctrines at the time. Now the church supports this theory, and we can get into how they sort of like honor Copernicus now, but know that at the time it was sort of like risky business. All right, so how did this affect other areas of science? Well, you have example here. Francis Bacon, right? Now he was from England. Now he was a polymath, just like all these other people we've been mentioning. Not only was he sort of like a scientist and a mathematician, but a statesman. He was the Lord Chancellor of England. He was born in 1561, which makes him just 3 years older than Galileo. And he's like, you know what? We've been finding out that we're wrong about things. Like we used to think that the Earth is the center of the universe, but no, it's the sun. Like, can you imagine going to school and finding out like, oh, by the way, everything we taught you is wrong. Sorry, my bad, made a mistake, right? What else is wrong? What else have they been telling us that's wrong? Is 2 + 2 really not 4, right? So how do we sort of regroup and make sure that what people are telling us is right? He says, well, you have to experiment. People, get out there, experiment. Even things you think you already know, experiment to prove it's true. And that's where the scientific method comes in. We've been discussing in our class and, of course, in your science classes. Like what could you experiment? What's the best way to make bacon? Probably not, but for real, right? Experimentation is important. And the next part of the unit is going to be on the Enlightenment. So I want to sort of give you ideas of how the scientific revolution and the Enlightenment, which seem like 2 completely different things, are actually related. So here's our buddy Rene Descartes. Rene was another polymath, right? He's a mathematician, wrote about math, but also wrote about philosophy and all sorts of things. He was from France. He was born in 1596. So he's the youngest one here, the little chicken of the group. Does that make sense, little chicken? I don't know. But he's like, you know what? Bacon is right. All right. We need to experiment. But once again, what else are we wrong about? You need to doubt everything. Doubt it. Do you exist? Is this computer you're watching on really there? Is it not in your mind? How do you know anything is real? Do you really go to our school? Are you really in my class? Do you really need to submit this Google form? Is the sky blue? Are Brussels sprouts disgusting? Yes, they are. And how do you prove that? Okay, you need to use lots of things like your brain. You got to use reason, okay, logic. Let's test everything and then take everything you think is true, but test it to prove that it's true. And we'll talk about in school, like how do you sort of do that? He's famous for a lot of things, but I want you to be familiar with this saying of his, cogito ergo sum, is in Latin. What does that mean? It means I think, therefore I am. In other words, you have to even doubt that you exist before you can prove anything else true. So if you doubt that you exist, how do you prove you exist? How do you know that you exist? Is it just because you can see yourself? Because what if your eyes are fooling you? I'm sure sometimes you see things that aren't really there because you can touch yourself. Well, sometimes you might feel something that really isn't there. But the fact that you're doubting yourself proves that you exist because you would think. All right. I hope your brain's hurting a little bit. It's going to hurt some more next class. Can't wait. Okay. So, lastly, we had a quote in class on Isaac Newton. We're going to talk more about him. I just want to briefly mention this idea that now he said we have all these laws we need to discover. Like, why is it that these planets rotate around the sun? And why do they rotate in ovals? Does this start to contradict the idea of God, right? Was Galileo really contradicting? Was it the church authority or was it God? And scientists and philosophers start to suggest how science and God can both exist, right? This is still a debate people think about today. And Newton's explanation was the universe is like a giant clock, right? It takes all these little gears that all need to run to make it work. And he says God took that clock and he wound it up and he set it. Okay, we'll talk more about this idea and the different things related to it. But he sort of called God a big clockmaker, like co-work clock, set forth your laws and theories and motions and gravity and all those sorts of things. Work. All right. So there's so much here that we can dissect and talk about more and make our brains hurt. Science is not just simple equations. It's stuff that should make you think. And it's stuff that changed the way society exists, the way we thought about the world around us. It is social studies. Science is not just science. Okay? If you have any of these questions, please bring them to class. We'll have a lot to talk about, and I can't wait to see you then. All right, cogito ergo sum, everyone.